So next is programming with Raspberry Pi. So before that, there are some commands that which you already yesterday discussed in the Raspberry Pi commands. That is general commands for Raspberry Pi is Raspberry config, as we already discussed, configuration settings menu, clears the data from terminal. Date command, it is going to display the current date. Reboot the system immediately. Shut down the system immediately. Nano example.txt opens example.txt in the text editor Nano. Power off to shut down immediately. And shut down -H. Suppose if I am going to specify the time, okay, whatever the time you are going to specify, so it is going to shut down at particular time. Say for example, shut down -H 1:22, right? So to shut down at 1:22 a.m. Okay. So you have to give whether it is a.m. or p.m. Okay, at that particular time, it is going to be shut down. Okay. Then the next is the apt get update. That is the synchronizes the list of packages on our system to the list in the repositories. Use this before installing new packages to make sure we are installing the latest version. apt get upgrade, it upgrades all of the software packages we have installed. StartX, it opens the graphical user interface. Okay, and there are commands which are related to some directory and file commands. So that is the mkdir, that is a new directory which creates a new directory named new directory. Move new folder moves the list or for directory name to a new folder or to a specified location. rm new file text deleted the file with a new file text. rmdir, that is a remove directory. New directory deletes the directory which is created already there in your. So it will delete the directory only if it is empty. Okay. Then the touch new file text, it creates a new empty file named new file.txt in the current directory. Okay. Cat new file.txt, so displays the contents of the file new file.txt. Okay. Then cd, cd, as I already discussed in the previous class, that it changes the current directory to the specified directory. Then ls-l, it lists the files in the directory. So I already told, list out the current directory files. Next is some of the networking and internet commands are there to work on the Raspberry Pi commands, right? And iw-config, so to check which wireless adapter is currently active. It is going to check whether which directory is currently active. Then if-config, okay, this is the wireless connections connection status. If you are going to give if-config, it is going to check wireless connection status. Ping, it tests the connectivity between the two devices connected on a network. Test the connectivity between the two devices connected on a network. Next, wget, http website.com, so downloads the file new file.txt from the web and saves it to the current directory. Next is a Nmap. This is a computer network security tool, and it uses it is used for scanning the network and list connected devices, protocol, port number, and other information related to your the connect nmap. Okay, so IW list WLAN 0 scan. This is also one of the network security related tool only. It lists list of currently available wireless network. Okay, and there are some commands related to the Raspberry Pi command. System information commands cat procedure memo information. It shows details about the memory. What will be the status of your memory, right? So cat proc version, it shows which version of the Raspberry Pi we are using. So it shows the version of your Raspberry Pi which you are using. Next is the df minus h. I already told that it shows the disk space, right? So information about your availability of the disk space, how much is there left out in your disk space. Okay, df slash, so shows how much free disk space is available. And free is also one command which shows how much free memory is available. Okay, host name minus L shows the IP address of the Raspberry Pi. Okay, then L sub B SUSB, it lists the USB hardware connected to Raspberry Pi. Okay, then VEGENCMD measure underscore temp. It shows the temperature of the CPU. Next, VCGENCMD get mem arm and VGNCMD get mem GPU shows the memory split between the CPU and GPU. Okay, these are the some of the commands which are available for the Raspberry command line. So now come to the Raspberry Pi, the programming Raspberry Pi with Python. So in this section we are going to learn how to get started with developing a Python programs on the Raspberry Pi. Raspberry Pi runs Linux and supports Python out of the box. Henceforth, you can run any Python program that runs on the normal computer. However, it is general purpose input-output capability provided by the general purpose input-output pins on the Raspberry Pi. You have seen the GPIO, that is a general purpose input and output pins, that those are, right? These makes it useful device for Internet of Things. Raspberry Pi can be interfaced with variety of sensors, actuators using the general purpose input output pins, and also SPI 12C and serial interface input from the Raspberry Pi can be processed and actions can be taken. For instance, if you take example, sending a data to server, sending an email, triggering a relay switch, these are the some of the examples. So Python is a beginner friendly programming language that is used in schools, web development, scientific research, and in many other industries. So that is we have the some of the programs that we are going to add two numbers, right, and to roll the dice to find the IP address of Raspberry Pi, and there are some examples to generate a password, to print Fibonacci series, to check for Armstrong number, to display a calendar of a given month of a year. Okay. So even what are the programs we are going to develop for using the other programming languages, right? Even Python also can be used to write the to write the Raspberry Pi programs, right? So for example, you take you already familiar the Python development and application subjects, how to implement the Python program, right? So I will tell you, suppose I want to print a message in Python, I can give print bracket, okay, within the double quotes you can give hello world, then close of the parenthesis. So that message is going to display the hello world. Hmm? And then suppose I want to add two numbers of integer type, a or floating point data type, anything you can take. Either you can input the data or you can assign the constant values to those variables, right? And a is equal to 1.2, b is equal to 5.3, sum is equal to float of a plus float of b, means it has to be converted. That is, we are taking the two floating point numbers, that is why we are going to give float the number variable name, okay, and float b another variable name, okay. Then after finding the addition of these two numbers, the result is stored in a sum variable. So we are going to, using the print statement, we are going to display the value of the sum. The sum of 0 and 1 is 2, and format will be a comma b comma sum. That is a value, b value and sum. What is the addition of both a and b? Okay, next. Suppose I want to roll a dice. Minimum is 1, maximum any dice will have 6 faces, right? So maximum is 6. Roll again, we are going to set the boolean variable as a true, and while roll again is equal to s or roll again is equal to capital Y, that is a true. If it is s, print rolling of dice, print the values are, print random, random of min comma max, right, and print random comma random of int min comma max. That is a minimum value and the maximum value of your dice. We are going to take the, we are going to print the rolling dice values if you are rolling again and again, okay. So that is how we are going to display the value of the dice, okay. They may ask in the examination, write a program to implement the these values, okay. Then so program to find the IP address of your Raspberry Pi. Sometimes I want to find the address of the Raspberry Pi. So import URL lib. We are going to importing the uni resource locator library files. Then import RE. Then print will try to open this URL in order to get the IP address. URL is equal to http colon check if dot dynds dot org. It is a DNS server we are going to open, and we are going to, currently what is the directory we are working, that we are going to get it and print the URL. So that is the only command where, so URL is equal to http colon slash check IP address dot dynamicdns.org, DYNDNS, okay, .org. All your URLs has been stored in that location, Okay. So when you are going to give like that, then it is going to take that it is going to extract the value what is present in that particular URL and it assigns to the URL from the DNS server and it is going to print the value of the URL. Okay. Next is program to generate the password. When I want to generate some password, okay, I am going to take the ASCII letters and string punctuations and what are the string digits. Okay, import string from random. Sorry. So now, so if I want to display the password, generate a password, then I am going to import the string from random. Import characters will be is equal to string ASCII character letters plus string punctuation plus string digits. So what are the characters I am entering as a password, right? And I am going to use a join choice character for x in ranges from the ran random of integer 8 comma 16. You know that minimum 8 characters will be the password. Okay, that is the reason why it is given 8 and maximum is 16 is given. Okay. Now, any password will have the digits, okay, and the special symbol and the characters. That is the reason why string ASCII letters plus string punctuation plus string digits is given. So, any password of yours will must contain the digits, must contain the letters, must contain the some special characters. Okay. So next is as we are already know that your password characters will be minimum 8 characters and maximum of 16 characters, right? So that is the reason why we are going to give the random int of 8 comma 16. Okay. Then whatever the password it is going to generate and it print the password. Okay. The next is program to print the Fibonacci series. What do you mean by Fibonacci series? First of all, we know that the Fibonacci series is nothing but the addition of the previous two values will be the result of the third number. Right? Next number I can say, not third number, next number. Say, initially we are initializing 0 and 1. Okay? A is equal to and B is equal to A comma B is equal to 0 comma 1 means A is equal to 0 and B is equal to 1. With these two digits, we will keep on generating the Fibonacci series. How means, see for example, A plus B is equal to 0 plus 1, 1. That will be the next number. So in the series it is already 0, 1 are there and one more 1 is going to be added. Addition of the previous two will be the result of the next number. So 1 plus 1 will be is equal to 2. Okay. So next number is 2 plus 1 will be is equal to 3. So it's keep on incrementing that means keep on adding the previous number, previous two numbers and that will be the result of the next number. So 1 plus 2 will be is equal to 3, right? And 3 plus 1, 3 plus 2 will be is equal to 5 and 5 plus 3 is equal to 8. 8 plus 5 is equal to 13. Like this, the addition of the previous two numbers will be the resultant of the next number in the series. Okay. Now, the so while B is less than 200, up to 200, we are going to print the numbers. Print B. So the resultant will be stored in the B. So we are going to print the B. A comma B is equal to B comma A plus B. So we are going to do the exchanging of the values. So here what happens? B value is going to store it in A. Again, that A plus B will be added and that will be stored in the B. That is the result. Okay. See, the statement will be like this. A comma B is equal to B comma A plus B. Got it? Okay. Next is that is how you are keep on generating the numbers up to a specified number. Suppose if we are going to give a 200, then until B reaches the less than 200 value, it's keep on calculating the B value and printing the B value. So next will be program 2 for Armstrong number. First of all, we'll understand what do you mean by Armstrong number. Armstrong number is the one, the cube of any digits, addition of the cube of any digits will be the result of that number, right? Okay. Suppose say 3-digit number is there. When you are going to cube all the 3-digit, and that will be is equal to the number itself. Okay. I'll tell you one example. Say, for example, you have 3-digit number. Say, example 111. Okay. And the Armstrong number when you are going to cube individual digit 1 cube plus 1 cube plus 1 cube. Okay. So what will be the answer? So 3. Right. Okay. So that the cube addition of the cube of individual digits will be is equal to sum of that number. We call that is a Armstrong number. Okay. Now we can write that logic. You people are familiar with the logic of finding the sum of the individual digits and reversing it. Same logic you can do it. Only thing is we have to do the sum of the individual digits of the cube. Okay. So if number is equal to initial sum, okay, whatever the number you have entered, that must be equal to the sum of the cube of the numbers. Okay. Then if that is same, we are going to print it is a Armstrong number. Otherwise we are going to give it is not a Armstrong number. Then there is a program to display calendar of a given month of the year. So import calendar. For this what we have to do? We have to import the calendar. Then after importing the calendar, here we are going to set it as a whichever the year you want, 2017 or 2018, 19, 20 also. Month will be is equal to 11. So suppose I am going to give like this. 11th month means November month of 2017 calendar is going to be displayed. So print calendar dot month YY comma MM. YY which year? 2017. Month is 11. So it is going to display the character of the November month. And there is a program where you want to print the blinking LED for Raspberry Pi. Okay, Raspberry Pi plus SD card, you need it. Monitor plus HDMI cable, keyboard and mouse and power supply. One red LED and one blue LED and 2.1K resistors. Two 1 kilo resistors, right? So description, what we can do is we can look at an example of controlling the state of LEDs from on to off state or vice versa from Raspberry Pi. So schematic diagram of the connecting an LEDs to Raspberry Pi box shows how to turn the LED on or off from by using running the code given. In this example, the LEDs are connected to GPIO pin 17 and 27 respectively, which is initialized as output pin. The state of the LED is toggled by executing the two programs given in the box. Having the code changes the state of the LED twice between blue box having the code uh, runs an infinite loop to flicker LEDs from on or off state every second, which is going to run the code given below and observes at the desired output. Okay, blinking LED. So means for every 1 second, so you have to set the pin on and off LED, right? So you are going to give the delay time will be is equal to the delay time will be is equal to the 1000 milliseconds. So means for every 1 second your LED is going to be blinking. Okay. So that is LED is going to be blinking means sometimes it is going to for a 1 second it will off and for another 1 second it is going to be on, right? So like that we are going to do the blinking of the LEDs. Okay, we can use any LED. Okay, of that no matter whichever the color you want, red or blue or green also no problem. Only thing is what we need to give the blinking of the LED for every second. Okay, so it's keep on displaying the it is keep on blinking the LED for every second because delay time for on and off is given as the 1 second, that is the 1000 milliseconds. 1000 milliseconds will be is equal to the 1 second. Suppose you want LED to blink for every 2 seconds, you can give 2000 as the millisecond delay time. Okay, delay time should be mentioned only in the milliseconds, and that milliseconds is going to be converted into the seconds. That is 1000 seconds will be is equal to 1000 milliseconds will be is equal to the 1 milliseconds. Okay, like that it is going to display the LED on and off, on and off. Blinking is what? It is going to switch on for some time and it is going to off or switch sometime. Okay, that is how your LED is going to work on and off. Okay, these are the important programs you can expect from for your exams, right? That is the Armstrong, Fibonacci number, addition of two numbers, printing the hello world message, right? And to add, to roll a dice, and to generate a password, okay? To find the IP address of Raspberry Pi, then the calendar to display the calendar of a particular year or month and year, so you can learn that. Okay, and so blinking to display the blinking LED also. Okay, these are all about the uh, programs. Next come for the wireless temperature monitoring system using Pi. How we are going to your Raspberry Pi is going to find wireless temperature monitoring system will be done with the use of the Raspberry Pi. So where in Raspberry Pi, so there is a inbuilt Wi-Fi which makes the Raspberry Pi to suitable for IoT applications. That is the reason why your Raspberry Pi is suitable for the IoT applications. Okay, so that by using IoT technology, This monitoring system works by uploading the temperature value to the ThingSpeak cloud. By this project, you can able to learn to how to handle the cloud-based applications using API keys. In this monitoring system, we used the ThingSpeak cloud, the cloud which is suitable to view the sensor logs in the form of a graph plots. Here we created one field to monitor the temperature value that can be reconfigurable to monitor a number of sensor values in various fields. The basic will teach you how to work with the cloud by using LM35 as a temperature sensor to detect the temperature and to upload those values into the cloud. Okay. So next is the what is the requirement if I want to run a Raspberry Pi and the Raspberry Pi libraries to be used in order to work on the Python libraries in order to work on the Raspberry Pi. So the hardware requirement for running any Python application is a Raspberry Pi board, okay, SD card, power supply, VGA to HDMI, converter optional, MCP 3008 ADC IC, a temperature sensor, okay, LM35 is the specification of the temperature sensor. And software requirements is Raspbian Stretch OS, SD card formatter, a Win32 disk imager, or if you can have a etcher also, and Python libraries which are used RPI, GPIO as to access the GPIO pins of Raspberry Pi, time library for time delay, and URL library too to handle the URLs using Python programming. Sometimes when I want to display the URL of IP address of your Raspberry Pi, right? So you require this URL library too to handle the URLs using the Python programming. Now there is one specified temperature sensor, that name is called as a DS18B20 temperature sensor. Okay. Now this DS18B22 is a one wire programmable temperature sensor from the Maxim integrated. That is a Maxim integrated is nothing but it is when integrated. You have the Rossby so temperatures, right? So involving this temperature sensor which reads out a temperature and records onto the terminal. So this temperature sensor, what it does, it reads on the temperature, okay, out and records onto a terminal. Okay. And this DS18B20 temperature sensor is a Raspberry Pi board box, shows a Python program which records the temperature read by LM35 temperature sensor. This example shows how to get an analog input from the general purpose input output pins and process the input. An infinite loop runs over the sensor which records a temperature every second. Compile the code given below and upload it into the Arduino UNO board to observe at the desired output. Okay. Now there are some light sensors also. Raspbian Pi is also having the light sensors. Okay. So these example involving the light sensor which leads to the intensity of the light and records it and text file. Okay. So LDR sensor to Raspberry Pi board box shows a Python program which records the intensity of the light to text the file. This example shows how to get an analog input from general purpose input output pins and process the input. An infinite loop runs over the sensor which records the intensity of the light with the date and time stamps. Every second, compile the code given below and upload it to the Arduino UNO board to observe the desired output. Okay. So this is what about the light sensors. So you have some passive infrared sensors, Raspberry Pi, SD card monitor, HDMI cable, keyboard, mouse and power supply, one red and one blue LED and two 1K resistor push buttons, and these are all must be there for this the passive infrared sensors, right? A jumper wire, breadboard, buzzer, LM35 temperature sensor, LDR light dependent resistor, passive infrared sensor, etc. Now let us look an example involving the PIR sensor which detects the motion of an object, and this figure shows that schematic diagram of the connecting in the PIR sensor to Raspberry Pi board, and this box shows a Python program which the motion of an object and the trigger a message as motion detected. This example shows how to get an analog input from general purpose input output pins and process the input. An infinite loop runs over the PIR sensor which waits for any of the movements across its boundary. Compile the code given below and upload it to the Arduino UNO board to observe at the desired output. So this is about the passive infrared sensors, right? So light sensors you have, temperature sensors you have, right? And the Raspberry Pi sensors, that is passive infrared are also there. Now, the applications of the DS18B20 temperature sensor is that measuring the temperature at hard environments, liquid temperature measurement, applications where temperature has to be measured at multiple points in pin configuration, right? So number 1, 2, 3, pin name is ground, VCC, and the data. Ground is connected to the ground of the circuit. VCC is powers the sensor and it can be 3.3 volts or 5 volts. And data is this pin gives output the temperature value which can be read using one wire method. Okay, now see the schematic diagram or the temperature sensor pinouts. Just see DS18B20 temperature sensor pinout, VCC ground data. Okay, then you have this DS18B20 temperature sensor. You can see here. Okay, so now next one is how we are going to connect the Raspberry Pi via SSH. You can access the command line of Raspberry Pi remotely from another computer or device on the same network using the SSH. The Raspberry Pi will act as a remote device. You can connect it to using a client or another machine. Set up your local network and wireless connectivity. Enable SSH. Enable SSH on headless Raspberry Pi. Add file to SD card on another machine. Set up your client. Okay, you have to, whenever you want to connect your Raspberry Pi via SSH, we need to do these things. Next is how we are going to access these temperature sensor, accessing temperature from the DS18B20 sensors. How we are going to access the temperature when you are going to connect this Raspberry this 1820 temperature sensor into the Raspberry Raspberry Pi board. Okay, it is a digital thermometer which allows to get 9-bit to 12-bit temperature measurements, programmable resolution. The temperature conversion time depends on the resolution used. For a 9-bit resolution, it takes at most 93.75 milliseconds, and a 12-bit resolution, it takes at most 750 milliseconds. The device is able to measure the temperatures from minus 55 degree to plus 125 degree centigrade and has a plus or minus 0.5 degree accuracy in the range from minus 10 degree to plus 85 degree centigrade. Additionally, this temperature sensor has an alarm functionality with a programmable upper and lower temperature trigger points. These thresholds are stored internally in non-volatile memory, which means they kept even if the device is powered off. The sensor communicates using the one-wire protocol, which means it only requires a pin from a microcontroller to be connected to it. Furthermore, each sensor has a unique 64-bit serial code, allowing multiple DS18B20 devices to function on the same one-wire bus. In terms of the power supply, the device can operate with a voltage between 3 volts to 5.5 volts, which means it can operate with the same voltage of ESP32 without the need for level conversion. Okay, this is about the how your 18B20 temperature sensor is going to be mounted on the Raspberry Pi board, and how we are going to extract the information from the 18B20 temperature sensor information regarding the degrees of temperature. Okay, so that is the